Okay, so how strong are your fraction skills? Well, if they're pretty strong, then you should be able to do this problem right here without the aid of a calculator. But a lot of people, matter of fact, I think most people are not going to get this right, not because they don't have basic fraction skills, but here we have a problem where we have multiple things we need to do with fractions, and that really increases your chances of making an error. Matter of fact, let's go ahead and take a look at the problem here. We have 1 plus 1/3 divided by 2/5 minus 1 plus 1/2. Now, if you notice, we have fractions within fractions. This type of situation in math is called a complex fraction. But go ahead and give this problem a try again. No calculators and take your time. Write things out so you can kind of limit your probability of making errors. But if you could figure this out, go ahead and put your answer into the comment section. I'll share the correct answer in just 1 second. Then, of course, I'm going to solve this problem step by step. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need assistance in learning mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. Okay, so let's go and take a look at the answer. The correct answer is negative 31 over 18. All right, so how did you do? Well, if you got this right, that is fantastic. Matter of fact, let's go ahead and give you a nice little happy face, an A++, 200%. And boy, let me kind of write that percent symbol a little bit better, 200%. Multiple stars. Matter of fact, this could be like a little mini final exam. If you got this right, I would just tell you to take the rest of the year off, enjoy your A++. But in all seriousness, that's very good if indeed you figure this out without using a calculator. Now, some of you out there that didn't get this right, you could have done a lot of these steps correct. And again, I think that a lot of people are not going to get this right, not because they're not doing a lot of the steps correct, but it's easy to make an error when you have a lot of multiple things going on in a math problem. That's why you really have to take your time, be nice and neat and organized, and of course, write all the steps out. But let's go and get into it right now. No big deal if you got this wrong. And definitely don't feel bad. My videos are never intended to make a person feel bad. So let's go ahead and see what happened for those of you that didn't get this correct. So let's look at the problem. Okay, so we have this big fraction and we want to add it to another fraction. So up here, we have this value is the numerator and this value down here is the denominator. So we need to kind of, look at this a little bit strategically, if you will. So we have a numerator and a denominator, and the value of the numerator is all this stuff, and the value of the denominator is all this stuff. Now notice I'm using parentheses to be explicit about this. This is basically one group up here. This is a value, which represents our numerator, and this right down here is another value that represents our denominator. So in math, when you have sums or differences, as we have right here, in other words, two things being added together or two things being subtracted together, whether they're numbers, variables, or fractions, it's not a bad idea to put parentheses around this, at least mentally, so you know that, oh, I have to actually do this first and this first, and think of this as one fraction. Okay, simplify this into one fraction where there's one numerator and one denominator, and then I can add it to this 1/2. All right, now this kind of brings us into another topic for those of you that are familiar with the order of operations. Matter of fact, let me write this out here. It's called PEMDAS. And I'm not going to fully explain it right here, but if you need help with the order of operations, I have a ton of additional videos on this kind of stuff. But the first thing we need to do when we have the order of operations is parentheses. We have to do what's inside parentheses. And here it's not clear that, there are parentheses right here, but really parentheses are groups. And this up here, when we have this fraction bar, this is effectively one group and this is effectively another group. So the way you want to approach complex fractions is to effectively look at, okay, I'm going to get all this right here. I'm going to figure this out, the entire numerator. Then I'll figure out the entire denominator. And then again, I'll have my one fraction. And then we'll start considering, what to do with this fraction. In other words, we'll have to add it to this fraction right here. But we can't do any of that until we simplify these two problems. And that really is kind of the P part in the order of operations, parentheses or groups. So we're going to basically have two little separate math problems right here to figure out. And our first is 1 plus 1/3. So what's 1 plus 1/3? Well, hopefully we can just say, well, that's just 1 and 1/3. Okay, 1 plus 1/3, we can write this as the mixed number fraction, 1 and 1/3. And then we can convert this mixed number fraction into an improper fraction. Okay, so just real quick, just to make sure you understand this terminology that I'm using, fractions where the denominator is low or bigger, excuse me, than the numerator, like 1/3, this is called a proper fraction. This type of fraction right here, where we have a whole number and then we have a little fraction off to the side, this is a mixed number fraction. This type of fraction right here is an improper fraction, and an improper fraction is one where the numerator is bigger than the denominator, and these type of fractions we can write into mixed number fractions. So it's important that you understand this terminology, but let's go ahead and take a look at it. We can easily do this right here. So 1 plus 1/3, we can write this as the mixed number fraction 1 1/3, and then we can convert that or write that easily as 4/3. Now, how do I do that? Or how did I do that? Excuse me. I took this 3, I multiplied by 1, so 3 times 1 is 3, and then I added this one right here, so that's 4 over 3, so 4/3. So this right up here, this numerator has the value of 4/3. Again, we're going to have a fraction within fractions. This is a complex fraction, but we're just going to methodically work this problem down one step at a time. Okay, so hopefully that makes sense. Now let's continue to move on. So we figured out what the numerator here is. 1 plus 1/3, again, is 4/3. So let's go ahead and write that right here. All right, now some of you out there could have started with the denominator, and that's perfectly fine. It doesn't make a difference, but this part of the problem is where we have to focus on first. So let's go and figure out what 2/5 minus 1 is, and hopefully you're like, oh boy, I can take this one and write that as 5 over 5 because we have 2/5 right here. And if you're thinking in those terms, that is absolutely correct. Okay, so at this point in the problem, I'm going to stop and I'm going to make some assumptions that you have some basic fraction skills. In other words, you know how to add, subtract, multiply, and divide, basic fraction problems, basically like the type of things that we're dealing with right here. Now, if you're struggling with this part of, if you don't even have basic fraction skills or you forgot this stuff, don't be discouraged. Let me give you some quick suggestions. One, I have a ton of additional videos on fractions, more basic problems, because this particular problem is a little bit more challenging, obviously, because we have a lot of things to do here. But also, I want to direct you to my Math Foundations course. It is a little mini course. You'll find a link to it in the description below. But basically, it's a 3-chapter course that teaches you all basic mathematics to include fractions. So if you really want to kind of, supercharge your math skills, your basic math skills, check out that course. But let's get back to this. So we have 2/5 minus 1. Remember, we cannot add or subtract fractions without having the same denominator. So in other words, if I had 2/5 plus 1/5, I could add these fractions because the denominators are the same, or are the same, so I just simply add the numerators. But here I have 2/5 minus 1, so how can I fix this up? Well, I can think of 1 as the fraction 5 over 5. Okay, so 1 is the same thing as 5 divided by 5, but here 5 is the common denominator, so all I have to do is simply subtract the numerator, so that's going to be 2 minus 5. And right here is a little bit of a twist because we have a negative number. So this is the same thing as 2 plus negative 5, which is negative 3. Now, again, if you're like, boy, Mr. YouTube Math Man, you're right. I've already made an error. Do not, get discouraged at all. If you check out my Math Foundations course, I also teach you about positive and negative numbers, i.e. what we call real numbers. In there. None of this stuff is difficult. It's just a lot of little skills that you have to learn. Okay, so this is the value of the denominator. So let's go back and make sure we understood. So we had 2/5 minus 1. We did all this math, and it turned out to be negative 3/5. And so we're going to put that in right here as our denominator. Okay, so now we have 4/3 divided by negative 5/3 plus 1. So what do we do right here? Well, again, this is what we call a complex fraction. But what we do is basically how I'm saying it. So just kind of listen to me kind of state this problem. This is 4/3 divided by negative 3/5. And that's exactly what you do. You say, okay, 4/3 divided by negative 3/5. We're going to go ahead and rewrite this problem as a division of fractions. And basically, we're going to do this. We're going to have 4 thirds, right? Well, this is actually our problem, divided by -3/5 plus 1/2. Well, this part of the problem is a division problem. We can explicitly write it this way: 4 thirds divided by -3/5, plus 1/2. Okay, that's exactly what we need to do. And at this point, we need to understand how to divide fractions. And you can't divide fractions unless you know how to multiply fractions, but this is actually pretty easy stuff. So let's go and take a look at the next step, which of course is to figure out what this is equal to. Okay, now notice I put this in brackets, but even if this wasn't in brackets, we have to do division before addition when it comes to the order of operations. So let's go ahead and take a look at how to divide these fractions. And as I indicated, to divide fractions, what we do is we change a fraction problem, or sorry, division problem, into a multiplication problem. And the way we do that is we flip the fraction to the right of the division operator. In this case, it's -3/5. We flip it upside down. So this is -5 thirds. Okay. Now, how do we multiply fractions? This is super easy. All we do is simply multiply the respective numerators and denominators. So this is going to be 4 times -5, which is -20, over 3 times 3, which of course is 9. Okay, so now we have -20 over 9. All this is done. So effectively, these brackets can kind of go away. So -20 over 9 plus 1/2. This is what remains. So let's go ahead and take a look at the final little problem to do within this. Basically, it's problems within problems. And that's why I said that a lot of people are going to get this problem, the overall problem, incorrect because it's really problem management. When you are dealing with a multi-step problem, it could be an algebra problem, doesn't make a difference. If you don't have the right kind of academic habits to write each step, double and triple check yourself as you are doing the problem, it is so easy to make an error, even if you know what you're doing. Okay, so here we have -20 over 9 plus 1/2. Now we have to start thinking about how to add fractions. And again, we have to be thinking about the LCD. So let's go and take the next step, which of course is having you quickly subscribe to my YouTube channel. I wouldn't stop this lovely math video unless I needed your support. Now, I am grateful enough, I'm definitely lucky enough to have quite a few subscribers. It's well over 520,000 people at the time of this video that have subscribed to my channel, which is crazy. And this year, 2023, as this is the year I'm posting this video, I think I got like 34 million views, which is even crazier. And that makes me feel awesome because it makes me feel like, hey, you know what? The content that I'm producing is reaching people. And, just from my years of teaching math, I know this stuff will, help people out. Okay. So if you're struggling in math, my main message to you is never, ever, ever give up. What you need is to work hard, okay, and work, correctly, but what you really, really need is great math instruction and encouragement, and that's what my channel is all about. And don't forget to subscribe as well so you get my latest videos. And let's go and continue on with this problem. So we have -20 over 9 plus 1/2. What do we need to do? Well, we need to add these fractions, and you can see that the LCD, or not the LCD, the denominators are not common. They're not the same. We have 9 here, we have 2 here. So we need to rewrite these fractions so that the denominators are the same, but there is an infinite amount of common denominators between 9 and 2. What we want is the lowest common denominator, and the LCD is 18. Now, again, if you forgot how to find the LCD, I teach you all that stuff in my Math Foundations course. You can follow the link in the description. But I think most of you out there are like, yes, Mr. YouTube Math Man, I understand you. Then that is fantastic. Okay, so 18 is the LCD. So we need to write both or rewrite both of these fractions such that they have 18 as their denominator. And here, to turn a 9 into an 18, I have to multiply it by 2. So I'll multiply the numerator by 2, so I have -40 over 18. And to turn this 2 into an 18, I got to multiply it by 9. But if I'm going to do that, I have to also multiply the numerator by 9. So this would be 9 over 18. Okay, so remember, we're just rewriting these fractions, but they are equivalent. If I gave you the fraction 9/18, I said reduce that fraction down, you would have the fraction 1/2. So we're just rewriting the fractions, but we're not changing the value of the fractions. Okay, so now we have the same denominators, 18 and 18. So what do we need to do in order to add these fractions? Pretty easy stuff. All we got to do is simply add the numerators. Okay, so here we have negative 40 plus 9 over 18. And again, we are dealing with positive and negative numbers. So negative 40 plus 9 will give us negative 31 over 18. And then we always look to see if we can reduce, and we cannot reduce this fraction. And there's not a need to write this improper fraction as a mixed number. Of course, you need to know how to do that, like 4/3, turn that back into a mixed number. But my advice to those out there, especially those of you are in a math course, if you're dealing with fractions, do not take your improper fractions and turn them into mixed numbers, because that step in and of itself, I have seen tons of people, tons of students have the right answer as an improper fraction. You just want to make sure it's fully reduced. But when you go to turn it into a mixed number, okay, in other words, you take this 3 into 4, you're going to divide 3 into 4, that's 1. And then you got 3, the remainder 1, 1 and 1/3, right? You take this step, but if you do it with here, you run the chance of making an error, and then you turn in the wrong mixed number fraction, even though you had the improper fraction right. And then there is a lot of tears, and you're like, but teacher, I had the right answer right here, but I'm like, but you told me this was the answer. And then, it's just not a good situation. So please heed my advice. Okay, so let's go ahead and take a look at another way to have done this problem right here. And I teach this in my courses, and I also teach this. Well, actually, I have quite a few videos on my YouTube channel about fractions that go over this. But this is called the bow tie method. Now, watch, I'm going to do this problem right here without even thinking about the LCD. So there is a specific method. If you want to learn more about it, go to my YouTube channel and look up bow tie method or fraction, how to add fractions without the LCD. Again, I teach this in my courses, but here is what you can do. You take this 2, and this is a specific pattern. We start with this denominator to the bottom right, and we're going to multiply it this way. Okay, so 2 times negative 20 is what? That's negative 40. And then we're going to start with this denominator to the left. It has to be in this specific order, okay? So exactly the order I'm telling you. So take this denominator to the bottom left, and you're going to take that and you're going to multiply across this way. So 9 times 1 is what? 9. Now, because this is an addition problem, we're going to be adding these two numbers. This is our numerator. Okay, see what I did? 2 times negative 20, negative 40, plus 9 times 1 is 9 over, and then you just multiply across this way. 9 times 2 is 18. And just look right here. This is the same thing we had right over here when we were dealing with the LCD. So we end up with negative 31 over 18. So this particular problem, if you know some of these little fraction tricks and hacks and shortcuts, and if you are really, really good with fractions, then you can manage this problem, without making a mistake. But a lot of people think that, oh, this isn't algebra, there's no variables here. This is basic arithmetic. It can't be that difficult. Well, you'd be surprised. Even the best of algebra students can make an error here because they'll underestimate the problem. They'll go too fast, and it's easy to do. So hopefully you were one of those that got this right. But if you didn't get this right, don't get discouraged. Hopefully you learned something. And if that's the case, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time, and have a great day.